you.
Thank you. So, do you see my screen?
Yeah, we're good over here.
Okay, great. Yeah. So, thank you, Michael, Mark, for organizing these online meetup. Like said, we want to talk today a little bit about scaling Neo4j on DCOS. And as we said, I'm working for the company behind DCOS called Mesosphere, and you can find me on the internet, Twitter, and on the DCOS community Slack, and on the Neo4j users Slack. And if I'm not responding, just mention me as long as you get your requested answer. So like, we have a bunch of Slacks around, so just ping me until you get the answer. But let's start with the actual question, do I need a Neo4j cluster? So you're able to have a big graph on a single Neo4j node, and you can do a lot of ciphers on one node. And the need for a cluster is basically for two use cases. So the first one is when you need high availability, and you need your cluster always running, and you don't want to have downtimes, and you want to accept that sometimes the node can fail, so you need more than one node serving your graph. And the other use case is when you need to scale out your graph database, when you have a huge amount of requests, and typically these are reading requests or reading ciphers. And so you want to add more and more nodes to serve all the requests. And this is the Neo4j causal clustering architecture, which was introduced in Neo4j 3.1. I think that was last December. And you have two kinds of Neo4j nodes. So you have the core nodes, and they are building the core of your cluster, and they are in sync about write requests. So when a write request occurs, the current leading core node replicates this write request to the following core service. So I talked about leading and following core nodes. So we have a leading Neo4j graph node, and this is elected through all the connected nodes. And they're building a quorum about these leading nodes. And on the other hand, you have these replica service. They're like intelligent and smart caches. So they are not key value caches, they are full-fledged Neo4j graph databases, but they are for reading ciphers and querying your graph. And the cool thing is that you can have specialized versions of these read replications. For example, you can have a special read replica for reporting and having all the caches around that in memory, and you have another one about analysis and all that stuff, and you can really fine-grain cache and serve and optimize your cluster. So this is really cool. So when your cluster is getting bigger and bigger, you can have specialized nodes for special purpose. And when we talk about big clusters and large clusters, large data centers, we see typically and often something like this. You have a static partitioning of your clusters. So you have basically, you have a cluster of clusters. So you have a big cluster hosting all your physical nodes, and you have sub-partitioned your cluster for special purpose. So for Neo4j has a subset of this cluster. You have a Kafka part. You have maybe a second Neo4j installation for testing or staging. You have a bunch of microservices and Flink and Spark and so on. So you have statically pinned application to specific hosts or specific nodes, which is not the best solution for some use cases. So the main disadvantage is that you need to optimize each subpart of your cluster against load peaks. So your microservice part of your cluster need to serve all the requests during high traffic times. So in the times where you don't have this high traffic, you have a lot of wasted resources because it's idling. So this is not ideal. And you have the other use case that you're not dynamic, is that you can't dynamically react to a failure. So when some nodes of the microservice part are failing and some other nodes are idling, you're not able to like shift dynamically nodes to this microservice area, and where you, from a part of your cluster where you don't need these resources. And what you actually want to have is something like this. So a multiplexing, so you're having nodes running different kind of applications, and you're more flexible in shifting your nodes between, so you're running application between your actual nodes. And this is what we call multiplexing and dynamic usage of resources. And when I'm talking this talk about resources, I mean something like CPU, memory, and disk, and IPs, and ports, and so on. These are resources in our terminology. So we want to have dynamic usage of these resources. And if something fails, I want to restart it somewhere in my cluster. And I actually don't really care where it started as long as it is started, like on my laptop. So I don't care which core, my CPU core, my IntelliJ, for example, uses, as long as it runs and serves my purpose. And this is exactly the place where Apache Mesos entered the game, because that's the intention it was developed. So let's take a short walk through history. So Apache Mesos was invented in 2009 at UC Berkeley at a class project from 3 students, and they wanted to write a system for fine-grained resource sharing across all applications in your data center, in your cluster. And with that time when you had these crazy scaling issues at Twitter, so you saw these fail-whale at Twitter quite often at that time, and they were really happy that at the beginning of 2010, they gave a tech talk introducing Apache Mesos to Twitter, and they pushed it really forward to publishing a source code draft of this paper. And then it was really fast that this project enters Apache Incubator, and soon after that, it enters Apache top-level project. Yeah, so let's talk a bit how this works. Oh, no, I'm sorry. I want to talk a little bit about the use cases about Mesos. So Twitter uses it still in production. So they're having a really huge cluster running their production on. And it was introduced on Airbnb. So if you ever book Airbnb, these requests are served via Mesos, and eBay uses it, Netflix uses it, and Apple uses this. Apple runs Siri on Apache Mesos, which is a really good example for these dynamic resource allocation. Because so each language of Siri is a different application, and you can scale up your language, Siri in your language, when all the people speaking this language are awake, and scale down when the people typically are asleep, and free the resources, and so other applications could reuse these resources. And this is really great a great example for the usage and the mindset of Mesos. And Mesos itself uses a 2-level scheduling. So Mesos in the core, just doing resource negotiation and resource sharing between so-called schedulers. And the actually scheduling decision where a task should be launched and what resource requirements this particular task has is done by the scheduler. The scheduler can have sophisticated logic about where to start and how to scale and how to handle failures and so on. But this is really different between like running NoSQL database and running a microservice architecture. So you have totally different kind of scheduling decisions to make if you want to operate microservices and if you want to operate a NoSQL cluster. So there's a couple of schedulers available. So you have schedulers for Kafka, Spark, Cassandra, Flink, and we have a so-called default scheduler. It's called Marathon. It's for container operations. And for Neo4j, we use these Marathon default scheduler for operating our Neo4j containers, but we'll talk about this a little bit later. And me as user, when talking, if I want to start an application, I'm talking to the scheduler. And I'm saying to the scheduler, hey, I want to start this container, I want to start this Cassandra node or whatever. And this scheduler is taking care of making smart scheduling decisions where to start my applications I want to have launched. And Mesos itself just doing resource sharing and accepting these launch requests. And this is a more technical slide, how the Mesos architecture works. So we have Mesos agents, and Mesos agents is just for starting and operating tasks. So there's no management logic on these kind of nodes. And we have Mesos master nodes, which are only for managing. So no computation is on these nodes. So no task running on these nodes, just managing the cluster and handling scheduler requests, and sharing resource offers from the agents fairly between all registered schedulers. And we have the third layer, the schedulers, which registers on the Mesos master and receiving then offers from the master. As you can see in this image, you can have a bunch of registered schedulers. So in this example, we have Marathon for container operations, and we have Myriad. And Myriad is a bridge for Yarn, so Hadoop to Mesos. But you could also have like Cassandra or Kafka as registered schedulers. And to complete this architecture picture, you could also do a Mesos master highly available, and there you have a zookeeper quorum about the leading Mesos master node, similar to the leading Neo4j node. So it's also by quorum. And if the leading master fails, the remaining masters would re-elect the new leader who is doing the master job there. When we're talking about this highly dynamic world where we can schedule containers all over the place, but we're also talking about database and persistent data, we need to talk about persistence and storage options. And in general, we have three kinds of applications. So we have stateful and stateless applications, and we have two kinds of stateful applications. So we have the stateful applications which were written for distributed systems, and they are scaling by adding more nodes like Neo4j or Elasticsearch on kind of these applications. And we have stateful applications which scale by adding more hardware, adding more CPU cores, adding more memory, like traditional single machine Postgres, SQL, or MySQL databases. And for these three kinds of applications, Mesos offers three kinds of storage options. So for these kind of stateless applications like Nginx or a servlet container, you get this default sandbox. And when the task fails, when the container fails, the data on the box gets garbage collected after a short period of time. And then we have so-called local persistent volumes, which we're using for Neo4j. And this is, you get a label space of disk on the local disk of the box. And when the task fails, this data will be kept. And you are able to relaunch the replacement task on the exactly same data again. And then the database, in our case Neo4j, can decide if the database want to reuse these data and just re-replica these delta between failure and restart, or if Neo4j say, hey, this data is old, I want to erase this data and fully replicate all my data in my cluster. So in the best case, you just need to replica a small amount of data, and you're prevented from like shifting a lot of data through your cluster if you don't need to. And you have local data. So you don't have a distributed file system, you have local data, and when you're developing a database, you want these high performance of local disk or local SSD or whatever. So, and don't want to be slowed down by a distributed file system. But on the other hand, when you're having these kind of single box MySQL database, you're relying on having a remote file system. because you don't have this inbuilt replication in your database. So you need to have some kind of distributed file system where you can store your data and save when your data don't get lost. So we have Mesos, we have some kind of storage options, and now we get the whole picture with DCOS. So DCOS is also an open source project. It's a distribution of around 30 other open source projects, and they're all about providing a modern platform for microservices and the ability to run on the same cluster like your NoSQL and big data and fast data and traditional database services all together on one cluster and one data center, as we call it. And the cool thing about DCOS is that you have like a common networking features, common security concept, one big roadmap with UI, CLI, a bunch of service discovery options and load balancers all over the place. And you have packages like the universe. And we show it in a minute. It's our interpretation of an app store for clusters. But when you enter DCOS, you see this. You see these, our dashboard. And our dashboard is an aggregated view on your cluster. So you get an aggregated view of CPU and memory and the healthiness of your cluster. So you see, is my cluster healthy? Do I have some problems? So the basic information you probably want to have when you woke up in the middle of the night because your phone rings and your boss is on the line to want to know why the shop is not running. So you need this aggregated information. And like I said, we have the universe. It's our interpretation of an app store. You can install a bunch of applications with just 2 clicks. You can install the Cassandra cluster, a Kafka cluster, Spark cluster, Jenkins, GitLab, Elasticsearch, and a couple of other things. And you can install Neo4j. And we have 3 packages in the App Store. So we have Neo4j, which is Neo4j core nodes. So when you install these package, you install the core of your cluster. And you can install Neo4j replica nodes, which are these read replication nodes. And you can install the Neo4j proxy. To explain the Neo4j proxy, I need to explain some kind of security concept in DCOS. So always when you start a container in DCOS, this container is started on a private agent in a private network, not exposed to the internet. And you have public agents, and these kind of agents are exposed to the internet. And when you want to debug or demo like we today, the data of your Neo4j graph database, you need to access those data which is kept inside your cluster. So we need this proxy to connect from the outside to the inner part of our DCOS cluster. So, and we're now doing that. So we are going to DCOS and we're going to the universe and we're installing Neo4j. And I do install and say install package. And what we then see in the service tab, so all behind service tab is basically Marathon, so container operations. We see these Neo4j group installing the Neo4j core nodes. And they're already installed and running, and we can have a look at some logs of this particular node. And you see service discovery of this node. So what we did with the Neo4j universe package, we took the original published Neo4j Docker images, the Neo4j Docker release, and we added a small shell script for doing service discovery specialized for DCOS. And this is what you see with this no DNS record found. So, and starting, we are just pinging DNS until we get a response for our database members. So this is these 3 IP addresses. And when we get all the IP addresses, we spin up our Neo4j cluster. And then starting with these initial discovery members. And now currently the database is waiting for the other members to join. So we can have a look at the other nodes. So the first is healthy. That's good. It's probably the point where the other gets healthy soon. So we can install the Neo4j proxy now. So the proxy relies on the existence of the core nodes. Therefore, we can install it at that point when the core nodes are running and healthy. Okay, and the proxy is running and healthy as well. So now we go to our public node. And this is mostly familiar to the audience, so the Neo4j UI. And what is important when launching this through DCOS is that you go to settings and disable bold, because bold is exposing these private IP addresses, and I'm not in the DCOS network, so it's my laptop. I'm not part of the cluster. I'm not part of this network, so I'm not able to connect to these private IP address. And then I can log in with Neo4j, and the default password is DCOS, and I can connect and say, hey, okay, and do a sysinfo. And then I see like one leading node and 2 followers. And then I can go back to DCOS and to the universe and say, I want to install some replication nodes. And say, I can install Neo4j replica, and I have advanced installations. I can say username, password, CPU, memory, disk requirements, and how many instances I want to install. But now default configuration is fine. I want to install 2 more nodes. And then we can go back to Service tab and see Neo4j, and we're seeing that these 2 replica nodes are being deployed currently. And they are started unhealthy, so they're not started the HTTP REST interface yet. So basically now the remote interface for communicating with the other node is started. And then we can go back to the Neo4j dashboard and do sysinfo again. And it usually takes some time for the read replication nodes to join the cluster. But when we redo sysinfo a couple of seconds later, usually these nodes should have joined the cluster. So here we are. So we see now that these 2 read replication nodes joined our cluster as well. So we added, just by doing a few clicks, more nodes to our server, to our cluster, which is pretty cool. And scaling works the same way. So I can just go to this view where I have all my Neo4j instances, and I have these replication nodes, and just can say scale. And I say I can scale to 3, adding 1 more node of these read replications. And it goes from running to unhealthy because we have a health check. So DCOS does health checks to Mesos, to Neo4j, so pinging every couple of seconds these HTTP endpoint. And if Neo4j is responding, everything is fine. But if Neo4j is not responding to these HTTP endpoint for a couple of times, DCOS will take care that this unhealthy application is replaced by another container running Neo4j, and this should be passing the health checks then. So when we now go back, so we scale just to 3 instances. When we now go back to Neo4j dashboard and do sysinfo again, we should see that we now have 3 read replications. So we can scale really easily. And I brought a demo connecting a real application against our cluster. And this demo is developed by Michael Hunger, and he did a Neo4j Twitter stream sync. So what we do, we are grabbing the Twitter stream and can search for some keywords. And in our example, we're searching for common keywords like happy and sad, because we want to have a big amount of traffic for our demo now. And the cool thing about this demo is that you can configure the application fully by environment variables, which is really good because you can inject those environment variables through DCOS really easily, what we see in a second. So we have these configuration. We can configure Twitter terms, like for what we want to search in our synchronization. Then we need to configure Twitter keys. So always when you're talking to Twitter, the API is secured with these keys, and we need to provide them. And we need to configure a Neo4j URL. So we need to point this application to our Neo4j cluster. And this is a Java application. So we can configure our application in the POM, so in the Maven file. And we did that. So this is a POM file, and we added 2 plugins to this build. So we added the Spotify Docker plugin to build our Docker container. And we're saying we want to publish this image to Docker Hub. It should have the name Neo4j Twitter stream. It should be based on the Java image and contain our jar file. So we can use these Spotify Docker plugin for building our Docker image. And then we have these DCOS Maven plugin, and there you can configure where your cluster URL is. And I configured my cluster, which we are already using. And I configured that I don't want to have strict SSL verification because it's a dev cluster and I don't have a proper SSL certificate. And when I configure these 2 plugins, I can do something like Maven clean package for building our Java package and our Java jar file. And then I can say Docker build to build the Docker file, the Docker image based on this configuration. And then I can say Docker push to push those Docker image to Docker Hub. And finally, I can say DCOS deploy to deploy these DCOS configuration to our DCOS cluster. But I already did these Docker publishing. And so I can just say Maven DCOS deploy, and I'm deploying my configuration to my cluster. But what I didn't show you yet was the Marathon configuration. So what I'm doing here is I'm posting a configuration, this JSON file to DCOS. And I want to start a container, so I'm using the Marathon container orchestration scheduler. And I'm saying, hi, this is Neo4j Twitter stream application. I want to use bold and routing protocol, and I want you to connect to this URL. And this is the DNS entry where your Neo4j database is available on. And you get, in our installation, you have 3 core nodes, so you get 3 A records behind this DNS entry. So you need to use bold and routing protocol because we are using write requests, and we are only able to write to leading core nodes, so we need bold routing. So with bold routing and this DNS record, you're able to write to your application, and it doesn't matter which concrete IP your leading core node, your needing core node has. You can just use the DNS entry and be safe that you can connect to your cluster and write to your cluster. We have Twitter keys. These are dummy keys. I don't save the file, so I'm using actually really keys for that. And my Twitter terms are happy and sad. I want to have 1 instance deployed. This instance should have 1 CPU, 2 GB of memory, a little bit of disk, and our freshly published Docker image. When we then go back to our DCOS UI, we see that we have this application running. And then we can go to logs of this 1 running instance. And we see that we have synced a lot of tweets to our cluster. So what this demo does is like fetching Twitter stream and converting it to a connected graph. So we have users, you have tweets, you have relations between them. So you have posted relation, you have mentioned relation, and you have links, and you have hashtags, and so on. And all these is reflected in the Neo4j UI as well. So you see when you go to this database icon, you can just click to user and do a fetch of 25 users, which we currently imported to our Neo4j database. And then we can have like a short dig into one of those. And we can expand these nodes and see what these guys are tweeting. So happy Thursday. Okay. No connection further on this tweet. Oh, he's tweeting a little bit more. Oh, so this one is connected. This is really cool. So we have this user tweeting about something and mentioning a hashtag, which is also part of another tweet of this user. And in this tweet, he mentioned 3 other users. And if we follow the links, okay, no further outgoing relations to those nodes. But we have examples, for example, queries. So the first query is I'm matching tweets and referenced links, so HTTP links, and then I'm returning these links, which the highest amount of occurrences. So we can see what kind of links currently hot topic on happy sad. And we see a bunch of YouTube videos, and yeah, real Donald Trump is always in the top 10, probably on the sad page of mentions. But okay, so let's go to the next one. So the last one is also really excited. So what we're doing here is we're fetching or matching users, returning the user, and the total amount of posts of this user. And then we're getting the 10 users with the highest amount of tweets in our database. And these are these 10 users, and maybe we expand some of those and getting, oh, he's really active. So let's see if we can expand this graph. Oh, I found the honeypot. So this is really connected data here. So you have these users, these tweets with this hashtag, and it's really connected. And probably if I open one of those, I get more and more data. And yeah, so in the back, our job is syncing continuously all the tweets from the Twitter timeline, the Twitter stream to our database. So our database has now, I think, 3 core nodes and 3 read replication nodes. So it's really capable of a lot of tweets. And it's really reliable in terms of high availability and scaling. And this is what's all about today in this demo, right? So that leads us to the last slide, I believe. These kind of slides. So kind of questions, and here's the link to the demo URL. And yeah, thanks for watching this screencast. Michael, do we have questions?
Thanks a lot, Johannes. That was really cool, and it was really quick to spin up the cluster and scale it, and then deploy the app as well. So we got a few questions, but they were all related. So one was related to licensing, and one was related to how you would configure an application like that to get the data, but you showed that it's coming from the deployment JSON package, right? And I think most of the other questions we already answered. That's why I think we can now start with the quick interview that we wanted to do with you. By the way, anyone of the viewers, if you liked what Johannes showed, please remember to like the video on YouTube as well, so that he gets a bit of thank you for that. So some quick questions, Johannes, for you. How was the first time, or where do you encounter Neo4j for the first time?
It was quite funny because you, Michael, visited our Java user group in the beginning of 2013, I think. So it was quite a few years ago. And we were really amazed by that. And we developed some smaller applications with Neo4j. And we got involved in this Neo4j community. And we did, together with a good friend of mine, we developed Neo4j Spring Data plugin for the Play framework, which we also really like to use for that.
Yeah.
So there was the first contact points where we met with the Neo4j world, and then we did.
I remember.
Kind of,
good. You had good barbecue as well, and that was, I like that.
Yeah, yeah, and we did some small applications. We did a like climbing database, which is also really highly connected between climbers and routes, and to climb. And when you did the first ascent, and to find other people in your local area, which are basically in the same grade of climbing, and you could connect to them and find other users in your kind of climbing area to go climbing with. And that's what we did with Neo4j in the first place.
Cool. What do you like about Neo4j? What's the things that?
Yeah, why did you decide to put it on Mesos? How come that was your one you decided to do?
Oh, I didn't get the question of Mark.
Oh, I was just saying, yeah, like continuing on from Michael, what made you think, oh, I'll go and put Neo4j to get that running on Mesos? What was the?
Why we decided to run this on Mesos? Because Michael told me that you're introducing this new kind of clustering architecture, and I was familiar with the clustering architecture before, and it was really interesting to get a sneak preview of these causal clustering, sorry. And I thought it was really good fit to enable on Mesos, because we have all the stuff which is needed to run big clusters, and we just needed to add these tiny shell script to the official Docker release of Neo4j to get it running on DCOS, which basically just do a dig on this DNS entry I showed you for configuration. Then when they dig, the DNS resolving is finished, configuring the database for these 3 or 5 IP addresses. It was really cool thing to do.
How long did it take you to go end to end from like having nothing to getting Neo4j to run on, to do the demo that you did today?
Oh, so I think Michael developed the demo this week or the last week. So the demo was really last minute.
Yeah. So
but to get the initial kickoff, like having the first place getting Neo4j contacted to DCOS and having the first cluster running was about, I don't know, maybe a week or maybe 2, because we have a bunch of service discovery options or networking features in DCOS. So we have, so in the first place we tried to use, actually we started a cluster by starting one node and then getting from Mesos the real IP of the host and the real ports, and then giving it to the next node and so on. So it was basically really easy approach, but a lot of manual work involved. Then we used virtual IPs to do these, but then we figured out that we probably want to have these kind of overlay networking features where all Neo4j nodes are included in this one overlay separated network only for Neo4j to these proxy to the outside. So we get this learning curve through a bunch of service discovery options in DCOS.
Yeah, so I guess what I've played around with this as well, and one nice thing about it is that it's pretty much like once you've got the Mesos cluster or the DCOS cluster up, you really do just go and click on that button, and it sets everything up for you. On some other frameworks that I've used, you often have to do the networking piece yourself, and it's a bit more fiddly. So it's quite nice what you've done.
Yeah.
We've got a question from your first answer, which is about doing stuff with Play. And it was just asking, did you do that with Java or with Scala?
Oh, the Neo4j Spring Data adaptation is usable from Scala and from Java. I think we can share the GitHub URL to the plugin afterwards, or in the Slack channel. Okay,
we've got a new question in, just as I say that. Now we're back to the DCOS bit again. The question is how do you set up, how's the persistence configured on the instances? For example, so the second part of the question is, where do they get their persistent initial storage from? And when the third core is added, how does that work? I'll let you do
so the question is about persistence, right?
Yep.
So so for Neo4j, we're using I can show you that. We're using local persistent volumes, and this is configured in these configurations. So what I want to say, when you're using a universe package, you install basically a Marathon JSON file, which is pre-configured. And so you probably, when you're operating these for a long time, you want to like version these JSON files to Git or whatever, so that you have this kind of history about that. But we're using local persistent volumes for our Docker containers. So this is configured here. And this is exactly what I was talking about a little bit earlier. So when one Neo4j node is failing, Marathon, as a container operation, will try to reschedule the replacement task on exactly the same data again. And this is these container path data. So root data is stored persistent and get this label that it should be reused. And by default, you have a size of 8 GB of disk space. But in this advanced installation setup, when you just click install in Universe, you could like enter 20 GB, 100 GB. So how many data you actually want to store. So
cool. So hopefully that seems to answer the question. We've got another one, which is about the proxy package. So the question is, with that, do you think that, or have you seen that has any kind of bottleneck? Is there only one proxy node, or would it be quite easy to do multiple ones of what proxies?
Yeah, you can have a bunch of proxies, but this is designed to have to run your database and your consuming services in the same cluster. And if you're doing this, you don't need these kind of proxy stuff. So our application, our Twitter sync, is working without the proxy. The proxy is just for us. So we are outside of this private network, but we want to have like access for debugging and demoing and accessing our data inside our Neo4j database. So we need this proxy to get access from the outside of the DCOS cluster. But when you're inside the cluster, so like the Twitter sync or other applications connecting to Neo4j, this proxy is not needed, and you should not install the proxy if you don't want to access from the outside. So this is really just for debugging and demoing purpose, this proxy to access it from the outside of the Neo4j cluster. Because inside it's not needed. You can just use this DNS record to connect to your database and use bold and bold routing protocol, and you're totally fine.
Cool. And I think that concludes our session today. Thanks a lot to you, Johannes, for presenting and for demoing and for building the package in the first place. And we want to let you know about the next session, where my colleague Ryan Boyd will talk about and demonstrate how he built the infrastructure and technology behind the Neo4j sandbox, which include Docker images of Neo4j, dealing with AWS, with ECS, with pulling data with Python, integrating with Auth0 and many things more. So there are lots of moving parts involved, so that you can get your really convenient and quick Neo4j sandboxes spun up. So please make sure to join the next Meetup event, and we are looking forward to see you there.
And if you want to try that out before a couple of weeks' time, neo4jsandbox.com. That's what Ryan will be talking about, the infrastructure behind that.
Yeah.
Cool. I think there's one more question there. We can answer that afterwards, I think.
Yeah.
But thank you to Johannes for taking the time to come and talk to us, and thanks to everybody for tuning in.
Yeah.
See you next time.
See you next time. Thank you. Bye-bye.
Bye-bye.